All right, everyone, welcome back. So this series of videos and finishing up for chapter 3 and finishing up unit 1 is going to be talking about marine sediments and how we classify them, how we sample them, what they look like, how they fall, tons of different ways that we're going to talk about. And I just want to kind of start here saying that when I say the word sediment, it can basically mean anything that's being suspended and moved around in the water. So you can think of like sand or rocks, or maybe you've seen sea foam before in some weird sort of way that's kind of sediment. But anything that is helping or is moving around the water, generally, not all the time, but generally closer to the shorelines. So we'll see some examples of that coming up. So let us finish up chapter 3. Okay, so when we're talking about marine sediments, we classify them in 4 main ways. First, by their size. Are they big? Are they small? Are they really fine? Are they kind of medium coarse? And think of the last time you went to a beach or some of the various beaches perhaps you've ever visited, and think about the size of the sand that you've seen there. Geographical location. So are they in the polar regions? Are they in the tropical regions? Are they more in our backyard here in the middle latitudes? Just kind of where are they at? And next is chemical composition. So basically, what are they made out of? Are they made out of animals? Are they made out of rock? Are they made out of shells, like these kinds of things? And last and most important is our origin story. So what's basically the most common method here is where in the heck did these sediments come from? Everyone loves a good origin story. One of my favorite origin stories, I'm a huge fan of the Hannibal Lecter series, so like Silence of the Lambs, not House of the Dragon, but there's other ones, and the origin story for that is Hannibal Rising. There's other origin stories that maybe you're familiar with, like Iron Man 1, that's his origin story, or the very first Spider-Man in 2002 with Tobey Maguire. Those are different types of origin stories that maybe resonate with you. Or if movies aren't your thing, perhaps in like sports, like where did LeBron James come from? Where did he start? And where is he now? That kind of thing. Kind of silly, but here we are. So I'm going to go through all 4 of these in detail coming up in a bit. But basically, we're going to look on whether they come from the land. Do they come from organisms? Do they come from water, basically through chemical processes of the water, or have they come from outer space? So this table here, let me move my face. This table here is looking at, this is from one of my previous textbooks. Your textbook has something similar, but I kind of like how this one's laid out a little bit better. So it has those same 4 types that I just mentioned and what they are composed of, where they come from, and the main locations in which they are found. And I guess I should have also said from the previous slide, geographical location can also mean, are they close to the coastline or are they out in the deep ocean? That's something to consider as well. Of course, you don't have to memorize this table by any stretch of the imagination, but I just think it's a nice little resource to consider when you're thinking of these different sediments. So the next thing that I think is really interesting in terms of sediment size is how fast they sink and then how fast or how far they move in the horizontal. So we're considering their movement vertically as well as their movement horizontally. And that's what this table, which is in your book, is trying to emulate here. So we're looking at very fine sand up into clay. So the further down we go this table, the more fine or the smaller these pieces are. So the big thing to keep in mind here would be the fact that the sinking rate lessens as we get smaller. So it takes longer and longer and longer and longer to fall in the vertical. And then this would be the average time that it would take in terms of days to fall our average depth of the oceans, which is 4 kilometers or 4,000 meters. Remember, those are the same number. So the biggest thing I want to point out here is that clay, that really ultra fine sediment, like maybe even smaller than your hair follicles, takes 47,000 days, which is roughly 128 years. So kind of takes a while for the really fine sediments to sink. And then what I also want to point out is how far they can travel horizontally in a current that's moving at a particular speed, in this case 5 centimeters per second. And this is looking at distance in kilometers. So one thing I just also want to point out is that this clay, this really, really thin or small, teeny tiny sediment can travel so much farther in the horizontal because it can be transported a lot easier, right? A silly way that you can maybe think about this is like, how far can you throw a bowling ball versus how far can you throw a ping pong ball? Or like a small, like a baseball or something. Like, think of something that's really obnoxiously large, like a boulder or a bowling ball, as I said before, and think of how far you can throw it just with your own strength versus how far can you throw a smaller, less dense ball. And then also thinking of like how fast they fall and how quickly, that kind of thing. I have a separate video actually going through an experiment of this that I will post below here. And then the next thing I want to touch into is the chemical composition of the various sediments that we see here. So chemical composition would be like, are they made of rocks? Are they made of glass? Are we made of bones or biological creatures? Or are we made of lava? Like, what are we chemically made up of? So that's another way that we can classify sediments. In our upcoming videos, we're going to go into the different origin stories in some kind of smaller, more digestible videos. So thanks for watching this video, and hang tight for a few more.